Hi, my name is N.A. Malakshmi Srinivasan from NAS BioVentures LLC. I'm the founder of the company. I'm a data scientist, bioinformatician, and a microbiologist. I have 14 years of work experience in data science, and I've been into analysis, corporate training, and teaching. My LinkedIn profile link has been provided. I would like to introduce to you certain aspects of bioinformatics before I get to the coding part. So I had developed a biological software using R. Now, the reason why I did so was because if we notice when we study, for example, patients using technologies where we obtain their genetic code, we eventually only study patients as a comparison, like how does it differ to a known reference genome in the repository, but we never get the complete genome of each and every sample. Though there are techniques and technologies for it, there is no quick way, and all the software based analysis focuses just on how does each and every patient vary from that of a reference genome which is there in the repository, but I never get a complete genome of each and every patient. So this is what the software helps in achieving in a very quick way, the software itself, by incorporating the variants or altering the reference genome, helps me obtain the complete genome of a given patient, and this is the fastest way to obtain such kind of information. So that's what the solution is, what I told. And Varincorp is the proposed trademark name. It allows researchers, scientists, biologists to obtain the complete genetic blueprint, that's a complete sequence of each and every sample, in order to analyze each of them independently as a biological system. So the industry market analysis we see is it has applications in clinical trial, genetic engineering, precision medicine, and evolutionary research. The competitive advantage, it elaborates a bit more. So it could be in evolutionary research. For example, I used this software, or rather the source of first original inspiration for developing the software was because I was dealing with new species, and when we did the analysis, I noticed that there are about 30,000 variations or alterations that need to be done to that of a reference genome in order to obtain this new species genome. So by studying it as a variant, I wasn't really sure I'm going to get that good an idea of its biological systems and pathways, and that's how I developed this software. So this will help in evolutionary research. Another best example is in clinical trials, where I could get an idea of the success rate of a given drug even before I get to the actual clinical trial. This software will facilitate in the process. It is just one aspect of the research. So it facilitates in the R&D process. Now, that's about its advantages. And coming to the coding front. So what am I doing at the coding level? At the coding level, I have a big data file. I'm altering that big data file at specified locations and regions to obtain another big data file. This is what I'm simply doing. But what is the precaution I need to take is that, say there are about 100 alterations to be done to the reference big data file. So they are at specified locations and regions. I have to ensure that only those elements which are to be changed or substituted should be substituted, and nothing else. Why I'm saying this is because when a reference big data file is undergoing alteration, it will be sequentially done. So now say I do the alteration at the location 20. So I alter, like, the element at 20, A, alphabet A is replaced by alphabet T. But the alteration which I do at the position 25, here instead of one element, the A, I'm going to replace that with TT. So what happens is Now, in the reference genome, what is at the 25th location, which had to be altered, is now at 26th location. So my coding has to take care of this, that only those elements which have to be altered, substituted, or replaced, or deleted are done or dealt with, and I don't uh, execute this process with any other element. So that was the care which had to be taken in the coding front, and I've managed with it, and even it's gone through a lot of testing and quality assurance, and so the purpose has been served. And using this software, I could get about 30,000 variations or alterations done to the reference big data file to obtain another big data file. Now, this slide is about, if you want to get the video of the transitions which were done, you can please find the link here, and that's the video, and you have the demo data file link as well. And an international survey done by Bioinformatics Inc. about this software, even that report can be obtained from the link. So please go through these links, and I would be happy to answer any further questions, or how this coding was attained. This is meant for commercial purposes, but I could always explain how this coding was achieved. Thank you.